Hello class, today what we're going to be doing is fenso buffering, aka double buffering. What double buffering is, let's run the program. And if you go like this, see how it shouldn't flicker, but it does flicker. So we need to make it not flicker, which looks like I have the wrong, oh there it is. No, that should work. But let's get a better example of this, because there still is some flicker that's just on the machine. So what we're going to do is we are actually going to double buffer the image file. So I'm going to take the image file, copy pasta, into a new class, paste this, and let's see if this works. Fenso buffering. No. So let's see here. What we need to do is first go line by line and explain this. We have our import statements, which we all know what that does. We're creating a class called fenso buffering that extends applet. These are the variables that we need. This is a new graphics, just like there's graphics G, it's graphics, buffer graphics. This could be literally anything. It doesn't need to be buffer graphics. It could be BG, it could be G2, whatever you want to do. As well as all of these. These don't matter. The image is an image, which is an off-screen image, which means how I'm going to draw this is I am going, so instead of going to Paint and drawing a L, a Z, an A, and a Y, what I'm going to do is, and then this gets drawn to the screen, and then when I want to redraw it, I need to go L, L, Z, A, Y every time. But each one takes a command to do this. Instead, what we do is we draw this image in the background, and then when we want to paint the image, we just paint the image. So if I want to paint the image again, I'm just pasting again and again and again and again and again and again with only one function call instead of multiple function calls, and that saves time, which makes it not flicker as much. So to get this to work, what we need is also the dimension, because this gets the dimension of the current applet size, so we can use that size to be the image size. So we're getting the size of the image, we're creating the image to be that XY width, width and length, and then we're setting that to be off screen, and then we're creating buffer graphics to be a offscreen.getGraphics. So it means get the graphics of the off-screen graphics. So what we're doing here is we are first clearing the rectangle, which clears the background. Then we're setting the color of G, not buffer graphics, to red. That's why when we run it, it was a black image. I'm drawing a rectangle at variable XY width length. And then I'm drawing the image back to G. So when I run this program, I want you to see that it's a black rectangle. When I go back in here and change this to buffer graphics instead of G, now it's red. So what I want to do now is I want to take this code and put it into this code. So we're going to open up both the codes at once. Image buffered. Imager buffered. So now what I need to do is, first off, let's get rid of, let's just go here. So I need these three variables over here, so I'm going to copy them over here. Then I'm going to initialize them by copying these inside my init. And then I need to paint, so I need to copy this at the top of my paint, because I need to clear the screen. Then I need to do this stuff, and then I need to copy this at the bottom, put this at the end of paint, which will draw it to the screen, and then I need to change these G dots to buffer graphics. And then when I compile and run this, now when I scroll this, it still flickers, but not as much compared to Imager, which if you see how they flickers individually, like the last three flicker more than the first one. If you watch it close enough, it does draw like this, where image buffered doesn't flicker as, that flickers just as much. But it paints the whole thing all at once. Whereas if I'm scrolling at this speed, you see how it's not flickering? Whereas if I scroll at this speed, it'll flicker a lot more. Does everyone see that? I'm trying to scroll at the same speed. This flickers a whole lot more compared to this. This is buffer graphics, and that's pretty much it, and this is how to implement them. To implement it, all we're doing is instead of using G, we're using buffer graphics and drawing the image to the image and then drawing off screen. The smaller the width and length, the better the image is. If I go to my buffered image and resize the image to be 500, and now I run it, it's not flickering as much. But it'll also be a lot worse when you get more images. So the more images you get, the larger the increase. So if I were to go and basically copy these all over again, and so instead of replacing all these, I'm going to do a find, replace. I'm going to replace G dot with buffer graphics dot, and I'm going to do all of them. And then it happens to all those all at once. And I did the dot so it wasn't just replacing all the G's. And now this still needs to be G. So when I compile and run this, lang. Now when I run this one, as you can see, there's a whole bunch more of them. And this shouldn't flicker as much. So you see the whole image flickers and not individual ones. Whereas if I go to this imager and run it, there you go. See how the top left one doesn't flicker as much as the other ones right there? And right there you can actually see when we see the full image of this one. Right there, right there. Where we actually see the image behind. On this one we don't see that image behind ever, no matter what I do. It'll never be there. But anyways, that's buffer graphics. I hope you learned something. I will see you later.